Hello. Imagine for a moment you're designing a castle 800 years ago and you have to build some staircases. How would you do it? What would be your rule of thumb for designing each step? Or maybe you're an architect today and you have a more sophisticated project you have to design. What would you do? Think about how many different types of staircases there are, and you can see this is not as simple of a question as it might seem. Here's a staircase that might go with your castle from 800 years ago. It looks pretty standard. But there's other staircases out there. Here's a steep one. Here's a shallow one, because of course the hill is long and shallow. Sometimes you have to go around the corner, or you may even need a spiral staircase, like this. So there's lots of possibilities for staircases, and just even getting started with figuring out how to tackle that sort of question could be tricky. So that's what we're going to be interested in this section, which is called Define the Problem. And we'll use the staircase problem as an example to work through this stage in more detail. But for now, let's just focus on what elements go into defining the problem. So recall, this is the first stage of the modeling process, and we're trying to take a real-world question and boil it down to something that we can actually have a chance for success. So there's several components, and so I just want to mention the key ones that you want to keep in mind as you are working through this stage. So the first step is to brainstorm. All right, what are all the potential aspects of the problem that goes into what you're working on? And once you've done that brainstorming, then you can start to ask follow-up questions. Again, most likely you'll have some sort of client that will be interested in this question, and so this will be a chance for you to go back to that client and say, all right, we've thought about the problem, we have some more questions. Once you kind of have a feel for what the client wants, or if it's your own personal question, what you really are asking, then you might see what sort of research is already known. So research what is known and or use estimation. Oops, what is known? Because sometimes a quick estimate is all you need to really answer the question, and there's no point in going beyond that. Or maybe this estimation or this initial research will give you a little better feel for what's really going on with the problem that you're trying to solve. And this will go back to possibly more follow-up questions. At some point, you're going to need to make assumptions. Remember, part of this stage is simplifying the problem, and assumptions generally do that. Another thing is to determine what is the key variables of this problem. Right, so determine the key both dependent and independent variables. Of course, the dependent variable is probably going to be the output of some model that you are working on. There's also parameters. So we need to identify parameters and their values. And then once we're done, the final step will be to state the newly defined problem. So the idea is that you will go through these other components here and ask follow-up questions, do brainstorming, figure out kind of where you're really headed, and then once you've done all that, then you can boil down to, all right, here's the problem we're really trying to solve, at least for now. And then as you go through the modeling process, you may have to come back, you may have to change your assumptions, you may need to ask more follow-up questions, you may even need to change some of these variables and restate the problem. But generally speaking, these are the sorts of things you're doing on this stage. Now, before we go into an example, one thing I do want to say a little bit more about is the difference between a variable and a parameter. So a variable, as you might guess, will vary, but a parameter will stay constant. Okay. And notice what is a parameter and what is a variable can change depending on what you care about. So just to give a quick example, imagine we're modeling the free fall equation. All right, you might have seen this in another class where if, let's say, time is my independent variable and I want the height of an object as it's falling, we're assuming no air resistance, then you might see it in a formula like this, where g stands for the acceleration due to gravity, so minus g over 2 times t squared, plus the initial velocity times t plus the initial height. So in this case, t is our variable, right? H is a function of t, so t is our independent variable. H of t is our dependent variable, right? Which of course corresponds to the x and the y axis. And then these other things are parameters. All right, so g, v naught, and h naught are parameters. Now, just because it's a parameter and it generally is constant doesn't mean that you might not change that constant depending on what you're doing. So maybe I'm interested in this height formula, but I want to keep it flexible for various heights or various initial velocities. Well, that's why I don't have actual numbers here. I still leave these as variables, but it's possible that I want to allow that value to change for different scenarios. So keep that in mind when you're trying to figure out which is which. But as a function, we're saying height is a function of time. Now, again, who's to say that time is always the independent variable? It could be that time is fixed, that I'm always going to be interested in the height after, say, 3 seconds. All right? And so let's say t sub m equals 3 is fixed. And now h naught is the independent variable. So notice in this case, my formula is still a function of something, h naught in this case, and now it's minus g over 2 tm squared plus v naught t sub m plus h naught. And now this h naught is the variable. It's allowed to vary, and I can plot a function with respect to that. H is still the dependent variable, and now Tm is one of the parameters, T sub m. Here, for now, it's 3, but it could be changed just like we changed H naught or V naught before. So that's a quick introduction to this stage. In the next video, we will work on an example where we analyze our staircase problem. We'll see you there.